Hi, thank you for joining me today. So we're all busy. I know, appreciate your time. My name's Madison Rye, and we're here to understand the importance of specialized systems in manufacturing. Today we're going to cover the purpose of core manufacturing systems and why it's important not only to have the systems, but also to have them integrated to pass information seamlessly. So before we touch on the purpose of these systems, let's start with the business needs. The infinity loop here you see represents a continuous feedback loop or in a product life cycle. So you start with product ideation. You have to have a target schedule, target requirements, and a target cost. You have quoting and ordering. Then you move on to product design and development, verification, validation, manufacturing and operations, shipping and logistics. You may have installation and commissioning, and then product service. And then all of that information that you learn along the way and lessons learned, you dump back into engineering so that you can continuously improve. So we call all this data that's generated during this whole entire life cycle here, plus the virtual representation of the physical part or system, the digital twin. So it's not just the CAD representation, but it's the CAD plus all of that data that allows us to make a really good informed decision when a change comes along. Performance calculations, jigs and fixtures, tooling, manufacturing, work instructions, maybe service manuals, all of that information. So then the digital thread is based on a use case, and it ensures the seamless flow of information of that digital twin to the right people at the right time in order to make informed decisions that are data-based and include all the information that's needed. So what we see today many times is the chain is broken here for many customers. An example is taking a BOM out from engineering, maybe your engineering system or Excel spreadsheet, putting in information for manufacturing and then either typing it in or importing it into the ERP system. That really breaks this chain here. You have possible errors from manual entry. It takes more time, and it has to be repeated when change happens. So really the goal of this is to digitalize this whole process to improve the product itself, to add tools for people to do their job better, safer, and provide the customer a better experience, among other things. When it comes to the systems to support digitalization that are driving customers today, the goal is to meet the requirements of managing this life cycle in the most efficient way possible while driving in quality and driving down cycle time. Many of the independent analysts, Gardner and Aberdeen, all those have looked at the main systems that are needed to meet that requirement, and they are CRM, PLM, ERP, and MES. So let's start with CRM. That's the customer relationship management, and that's where a customer interaction is really managed. So it's not just addresses and shipping information, but it's a history of sales, marketing, customer segmentation, all of the opportunities, forecasts for sales, really enabling the company to provide better customer acquisition and retention. Now, many of these also have customer portals, so you can log in and see where the order is, if you wanted to track something or a support issue. When you look at product lifecycle management, that's really about engineering. So product design, development, simulation, testing, quality information, maybe like FMEA, change management, compliance with regulatory standards, really all requirements, and the engineering BOM, not just mechanical, but also electrical and software as well. Manufacturing execution system, that's really to track the manufacturing processes in real time, making sure all of the things, resources like people, doing assembly work and whatnot, and raw materials to finished goods, all of that is managed efficiently. This helps reduce downtime for the equipment, and it also really ensures that the schedule will be met while tracking quality information from a manufacturing standpoint. Detection of defects, nonconformities. Is the person doing the work qualified to do the work? When you look at enterprise resource planning, ERP, it's really, it's about resource planning. It's inventory management, financials. You may have HR information, forecasting, builds for inventory, that kind of thing. It provides a comprehensive view of your business operations. And you might have other systems like warehouse management or building management, maybe IT/OT systems. But for design and build, these are the core systems. So it's not just important to have these systems, but they have to be connected so you have that single source of truth. the data can be shared across these systems, but it has to be available so that it has to also not involve manual work moving things from one system to another, because again, that's, you're going to break the chain. You're going to leave room for that manual manipulation, time it takes, the errors it causes, and then it has to be redone when a change comes. So you can see there's some overlap here too. Maybe ERP says, hey, I have a PLM module, or I have an MES module, and someone says, hey, we have a homegrown system we can use. So let's talk about the importance of specialized systems. So don't tell my mom, but she has really good advice. She's told me many times, don't use things in a way that aren't designed to be used. The first time she said it was when I tried to open a jar with my teeth and chipped a tooth, and the last time I heard it was when I tore my meniscus trying to use a knee board as a surfboard behind a boat, and it broke and caused all sorts of issues. So the same applies here. Use the systems the way they're intended to be used. When an ERP system adds some PLM functionality, it may be a short, quick fix, but it's not going to meet your future needs. Each system is really optimized for their specific function, and specialized systems offer more comprehensive features for their focus area. These specialized systems are really scalable for their growth, and they, again, have to be integrated to provide that holistic solution. So let's take, for example, using an ERP as a PLM system, which we've seen, people do. So ERP compared to PLM, like if you look at the product lifecycle, all that we saw, that infinity symbol, we start to understand really why it's important that we have the full functionality of each of these systems and then integrate them. So PLM's core function is really engineering data. We have the ability to really manage all of the data surrounding that product lifecycle. So we have integration to CAD or CAM or CAE tools, ECAD tools. So you have the ability to save right into a database or a volume right from that interface. Software development is another one, testing tools. All of this data can be revision controlled, connected to any other data that it belongs to, so that you can report on it and make sure that there's no discrepancy in which systems or parts or anything is involved, because it's attached, it's all linked. That gives you really a clear picture of what's happening. So in ERP, you're not going to get integrations to the core engineering tools, but you're going to have finance and inventory, human resources that you're not going to have, those tools you don't have in PLM. The focus really in ERP is operationals for producing the product. When it comes to BOM management, PLM functionality delivers the CAD BOM straight from the assembly. So you save, CATIA or NX or whatever CAD you're using, Solid Edge, SolidWorks, you save that into the PLM system, and you're going to get that CAD BOM right out of the gate. That's core functionality. And then you have the ability to create a true engineering BOM for software, mechanical, and electrical. And then you have product configuration capabilities allowing for 150% or overloaded BOM that can be used to configure down to a manufacturing BOM for connection to ERP, because ERP is really expecting that 100% BOM because that's what you're going to build. Core PLM functionality is workflow for complex multi-domain changes that are connected to the data which they belong to, and it allows for cross-functional collaboration needed for design for manufacturing, design for service, design for reuse, for circularity. Also, PLM ensures that the product meets the requirements and the standards. ERP manages the business compliance aspects like financial reporting. So let's talk about some, what we see in the real world. So when companies effectively use CRM, PLM, and MES systems and ERP together in an integrated environment, they save time, money, and they produce a better quality product. So the analysts say you can achieve 20% reduction in warranty, 40% improvement in time to market, 25% reduction in cost. And these are just a few examples of improvement. And I've witnessed this myself with an engine manufacturer when it comes, I'm tongue-tied today, an engine manufacturer that engaged in connecting their partners, their distributors, and they reduced warranty a considerable amount. I've seen engineering time reduced significantly in a manufacturer that went from 4 hours just collecting the data for an ECR down to 30 minutes. And then also the impact analysis, there were less errors and less rework in those ECRs because the information was there, tooling, quality. You could really do a true impact analysis. I've seen it with product configurator, companies whose manufacturing team said, hey, we create our own BOM because the accuracy of the one that we get coming to us is a really big issue. Now they have accurate, up-to-date BOM that was outdated, that was automated, and they sent that to the MES and ERP systems for kitting and building. I saw a company go from 50% on-time delivery to 90% on-time delivery. So these are all things that can happen when we have these core systems doing their job and connected. In contrast to that, I've been involved with companies that have homegrown systems, and they started out as a quick fix for something and added to over the years all this functionality. But then the people that knew how to develop it left the company, and now the people don't know how to change it, and they have severe issues, so they start plugging holes with people, and that's expensive. I've been involved with companies that have decided to let ERP drive the whole business, no PLM or MES system, and again, they're using people to fill the holes because the functionality that's needed isn't there. We've worked with companies that went down that path and are now pulling back and implementing PLM and MES to have the needed functionality for now and for the future, for scalability. So in summary, remember, my mom's advice, don't use products in a way that they weren't truly designed. Manufacturing companies really need to fill the full functionality of the right systems available for them to use now and to scale for the future. And also I wanted to mention too that before we even get to technology, we really have to start with the business needs that align with the strategy of the company. Then we look at process and functional requirements, and finally the technology that'll meet those requirements. If you'd like help with this or you want to talk further about it, don't hesitate to reach out. And anybody here or myself at Saratech. That's just what I wanted to cover today, so I will hand it back to Kelsey to talk about any questions.
We have a couple questions, yeah. So the first question is, would you recommend applying the same approach of use a tool for its intended purpose to the integration backbone, i.e. use the right tool as designed for integration as opposed to make a bespoke system fit with custom integrations?
Yeah, so I think that's talking about the integration piece, as a custom integration versus the tools that are out of the box, like for example, Team Center has T4EA to connect. There's a Microsoft Dynamics piece on the ERP side that is to increase that connects as well. So as opposed to like MuleSoft is a integration tool and making that custom. So I think it depends on what your architecture that you're looking at, because if you're gonna, if you want to use the tools that come with these systems that are out of the box have the ability to have the right hooks and levers to get into the system to pass the information that's needed to the other system. For example, if you want to pass BOM and attribute information, using the out-of-the-box solution to do that is a lot easier than using like a MuleSoft tool and coding it. But if your company direction is, hey, this is our standard integration piece, this is our middleware that we're using, and there's plans for like a service bus with a data lake or warehouse, you might have to look at something different like that.
Okay. And then our last question, unless something comes in, if you are looking at upgrading or implementing ERP and you don't have PLM yet, what is the recommendation on starting with PLM or upgrading or implementing ERP first?
Yeah, classic question. So we get this question all the time, and it is, so everything starts really in engineering. Your functionality has to start there because the design happens there, the BOM happens there, and you need to have that in place before you move towards MES and ERP to receive that information, because otherwise you don't know what you're receiving, to be able to, upgrade or move those systems. Um, and there, again, there you have to look at the business requirements too. So, if the business requirement is that one of those systems is outdated and you need to do an upgrade first, that might be a different story. But in terms of implementation out of the gate, things start in engineering and they flow downstream from there. So getting that in place first would be the recommendation there.
Okay, sorry, we have a couple more questions I didn't see, but I'm seeing them now.
Okay.
The next one is, what does PLM add if you already have MES, ERP, and quality software?
Okay. So the ability PLM adds the ability to, if you're designing something, you got to do it in CAD, you got to analyze it, you've got to test it. The and if you remember that infinity loop, the design and development, the verification, validation, those pieces all have a whole lot of data that gets generated during that time. The other systems do not manage that data and do not connect that data with the other data that it belongs to. So it's not really good enough just to put that data somewhere. You have to understand the relationship that data. Like for example, if you're doing an analysis, what's the relationship on that to what revision of the product you're on today? So the benefit of having that PLM system in place is that you get that ability to not only store, manage, revision control, all of that data, but you also get to connect it to what it belongs to. So it makes it easy for the user. You're in CAD, you hit save here instead of save on a network drive. It's very easy to do. And then the other piece is the workflow. It's, there's workflow around new product development. There's workflow that can be automated around change management. All of those pieces are included as well. There's the PLM systems have a huge amount of functionality. You can now even get out to the point where you can look at your carbon footprint for your product through the PLM system, because most of those decisions are made in engineering. What material am I going to use? What processes are going to be involved in making this thing? So the I won't go into all the functionality, requirements, costing, schedule management, change management. All those things can be in one system so that you relate it to the data that it belongs to, and when you complete the task, it automatically updates the schedule and the program overall. So there's just a ton of benefits, to having the PLM system. So that's a great question, and I probably could go on there for hours and hours about that. So reach out if you want more information. I'll be glad to take you through it.
Thanks. So another question is, you mentioned that the PLM would handle product compliance to requirements and that ERP would be more on the business finance side. Would manufacturing as-built live in a separate database, or do those get rolled into the PLM somehow?
Could you read that last part again?
Would manufacturing as-built live in a separate database, or do those get rolled into the PLM somehow?
So there's a number of steps to the BOM. I assume I'm talking about the as-built BOM. So the BOM starts with the CAD BOM, and then you have the engineering BOM, which allows you to align to, a design effectivity. So now you've got Rev A coming out on this date, Rev B coming in on this date. You can organize it differently. You can add non-CAD stuff there. You can do product configuration there. Then you move to the MBOM, and the MBOM really is, which you also can do in PLM with the tools now, is you align it to where it's going to be built. So you have this line, this area of that line or this cell where it's going to be built, and you have all of the tools that you need to what parts are consumed there, what tools are needed, what training needs to be done for the person who's doing that, all of that information. When it comes to a serialized BOM, you can do that either in PLM or in the the other in the ERP or MES. I mean, MES has to have a serialized BOM because that's you're going to build this today. There's several steps of that though. There's a master manufacturing BOM, and then on the line maybe something happened and they had to swap out a part, or there's a deviation or whatever. That's the actual as-built BOM. So that typically happens on the side of the MES system, or and gets recorded in the ERP system as well. But the master manufacturing BOM can be pushed from PLM as far as what are we planning to build versus what we actually built. Hopefully that makes sense.
All right, I believe that was our last question.